Welcome everyone to Suffolk County Council's launch event for the Innovation Network. LoRaWAN Network being set up in partnership with Norfolk County Council and New Anglo-Local Enterprise Partnership. I'm Simon Reed, I'm the IT Operations and Connectivity Lead for Suffolk County Council, and I'll be your host this afternoon. An interesting event set up this afternoon. Firstly, I'm going to hand over to Leader of the County Council, Councillor Matthew Hicks.
Thank you very much. Good afternoon, everyone. And as Simon just said, my name is Councillor Matthew Hicks, and I'm the leader of Suffolk County Council. And I'm really pleased to be here to welcome you to the launch today of our LoRaWAN Gateway Sensor rollout. And as we know, this is part of the Norfolk and Suffolk Innovation Network. As a council, we have continuously invested over the years in new technology to better connect our communities and our businesses. As we are mostly a rural county, getting the infrastructure in place to allow people to access the internet or to help monitor assets like buildings and streetlights can actually sometimes be a real struggle. And I'm really pleased to say that this project, with the new gateways already being installed on public sector buildings across the county, has overcome those difficulties and is another really positive step in our vision for a fully digital and well-connected Suffolk. I hope you'll take advantage of this opportunity to collect meaningful real-time data, which will help inform your business decisions in the years to come. Now, whether this data is used to measure existing performance or develop new products or services, or just actually better understand your audience or the environment, getting real-time data about today could actually be the key to unlocking the next big business idea of tomorrow. I'd really like to thank our project partners who've helped today, particularly Norfolk County Council and the New Anglia Local Enterprise Partnership for providing the funding needed to make this project a reality. Once again, it proves that we can always achieve more for Suffolk by actually all coming together and working together. I'd also like to thank all today's speakers for agreeing to join us today and for demonstrating the potential of the LoRaWAN technology and the network. I'm sure we will all find the presentations and the examples given inspiring, and I know they're very happy to also take any questions. But I'd also like to thank the wider team here at Suffolk County Council for pulling this project together in what has been a clearly very difficult time. And I'd also, while I have the opportunity, thank Simon Reed and James Reeve for all the work behind the scenes that has gone on to also make today happen. So it's now my pleasure to hand back to you, Simon, to take us through the rest of the afternoon. But many thanks, everyone, for joining us.
Thank you, Matthew. So we've got an interesting session lined up today. So we'll shortly be handing over to Mark Stanley from Thingitude to talk about what LoRaWAN is. We've then got a presentation from Matthew Applegate from the Creating Computer Club. We've got a presentation from Suffolk's own ADEPT programme, and then we'll go through some details around the wider deployment in Suffolk. If you have any questions, please use the Q&A section in the Teams meeting, and we'll pick them up there to answer towards the end of the session. And any that we can't answer today, we'll take them away and we'll get back to you with answers later on. So I'd now like to hand over to Mark Stanley from Thingitude, who's going to talk about LoRaWAN and some of its real-life example use cases.
Thank you very much, Simon. So I run a small business called Thingitude. We're based in Reading. We work with public sector, and we've also worked with about 40 odd businesses, helping them get started with the Internet of Things and with LoRaWAN in particular. So I'm going to talk about what the Internet of Things is, where LoRaWAN fits into that, a little bit about the technology, and then how people are using it and how you might want to get started. So when we talk about the Internet of Things, if you think about the internet that we all know, that's kind of the Internet of people. So it's a way of people sharing information with one another. and some of it's important and allows us to work in new and exciting ways, and some of it is videos of cats, and it's entertainment. In the 80s, some students at Carnegie Mellon University, they got fed up of wandering to their Coke machine to find it empty. So they hacked the Coke machine and connected it to their network so that from the desk where they worked, they could actually see whether the Coke machine had Coke in it, and also whether it was cold enough to warrant the journey down to the Coke machine. And that's the very first instance of the Internet of Things. Of course, it wasn't called the Internet of Things then, because the internet didn't exist then, and it wasn't until the 90s that the Internet of Things became a phrase. And it wasn't really until the last 10 years or so that we started talking about smart cities and smart homes. And I think people now are used to the idea that you might have a smart watch on your wrist, that buildings can be smart, and it's smart everything. That's all powered in the nuts and bolts of it with the Internet of Things. So it's connected devices talking to the internet and being able to share information with the other devices and indeed with other people. Why bother at all? So it's taken off a lot recently because the cost of technology has come down, and accessible technology has become very easy to get hold of the technology. But the reasons businesses and councils are involved in the Internet of Things, the main reasons, is it can improve decision making. So you can get real-time information such as, is the Coke machine empty or full, and predictive analytics. So okay, the Coke machine's been refilled in the last half hour. It takes 2 hours for the Coke to get cold. So in an hour and a half's time, I know it's worth going to get the Coke out of the machine. And it can provide you with new information. Improving the quality of service is important. And if you think, the example I like to use is a lift in an office block, or a block of flats even more, where if the lift breaks, it becomes really annoying for the residents there and disruptive, and everybody is unhappy. But the residents, when you speak to them, probably knew that the lift was going to break because it makes a funny noise. They just don't like to cause a fuss and phone up the engineers to say it's making a funny noise. Well, if you have a sensor in that lift, it can do that embarrassing bit for you, and it can log the call with the engineers, and they can come out and repair the lift before it actually breaks. And that way everybody's happy. The repair itself is less expensive and it's less damaging to the residents. It also means you can be monitoring things 24 hours a day, 7 days a week, rather than when people go around to do an inspection. So the money side of things obviously is important to everybody. You can reduce operational costs and you can enable new business models. Now, I'm not sure if you can see me well enough to see that I'm holding up here a little blue mousetrap. Now this mousetrap, it's connected to the internet, and when a mouse gets caught in it, or if the mouse gets away with the bait, a message is sent to the rodent control company, and what that means is that they no longer have to go around and routinely check all the mousetraps because they know which ones have been set and which ones haven't been set. So they can save an awful lot of fuel bills and people cost in just resetting the traps that have either caught a mouse or where the mouse has got away. And it also means that they can start charging premium rates for being able to empty a mousetrap quickly, which if you're a Michelin star restaurant, you might want that mousetrap to be emptied quickly. Whereas if you are a warehouse somewhere, a food warehouse, then emptying it once a week might be good enough for you. So you can have different pricing models. And the fourth reason, and this I think has come much more to the fore in the last year with lockdown, everybody wondering and worrying about people who are remote to them suddenly now, is improving people's quality of life. And that's where my business likes to spend its time. So we've been working on a project to make the streets of Reading feel safer to women students at night in particular, and also to help reduce the number of falls that older people have been experiencing. because that is something that leads to them going into care and the loss of independence, which is something they certainly want to avoid. I've got 4 examples of how business are using the Internet of Things here. If we start in the bottom left with the vaccines, now I think everybody these days certainly is aware that some vaccines require to be kept at some temperatures, and other vaccines can be kept at other temperatures. But what if the fridge breaks down? You need early warning of that. And there's a company, before I go further with that, it's true as well for fresh food and chilled food in shops and in restaurants, that you need to monitor the temperature of the fridges. And there's something called an HACCP report, a compliance report that you need to produce. And that's quite a bit of manual effort. Now, there's a brilliant company called CoolZone that has automated all of that using sensors in the fridges. And they've even designed temperature sensors now that can work at -80 degrees centigrade. So that makes it very suitable for monitoring things like COVID vaccines. Just above them, the funny pyramid shaped things, is a company close to you all in your region called Airponics, which is a startup company. Now, they're in the high-tech world of the potato, the seed potatoes in particular, and they have worked out a way to grow seed potatoes in an environment where there is no soil. So they actually grow them in a fog, and they use the Internet of Things to monitor the environmental conditions within their pods. So they know how warm it is and how moist it is, and they can very tightly control the parameters around which they grow their potatoes. And what that means is that they're then able to produce seed potatoes quicker than their competitors, and that's the technology that they're working on. There is a lot of interest in the care world, in care homes, both in terms of dementia and, as I mentioned earlier, preventing older people falling over. And then down in the bottom right-hand corner, there's a housing association in Wales called Barcode, and there's a guy there, Dean Marsh, who has been working with the Internet of Things, and one of the things he's been working on is the safety lights. So in any office, in any sort of managed housing, there's emergency exit lights, and they need to be tested. Again, it's a compliance thing. They need to be tested regularly, and he's been working with a company, and they've managed to get it connected to get the lights connected to the Internet of Things, so they can be tested automatically and report back if there are any problems, which saves an enormous amount of effort in terms of inspection costs. So I'm going to touch on the technology now. This is a diagram that tries to explain how the Internet of Things is set up. So over on the left, you've got sensors, connected devices. So that might be something like our potato growing area, or a full system, or the vaccines. And those sensors send data over wireless to gateways. And the gateways then forward that data onto the internet. And then from a network server in the internet, they get passed out to different applications. So, for example, if the lift breaks down in a block of flats, or rather, if the lift is making a funny noise in a block of flats, it transmits a message which gets picked up by a gateway, and then the network server forwards that on to a maintenance application, which then creates a piece of work for an engineer to go out and do the repair. And broadly speaking, that's how the Internet of Things works. So what I'm going to do now is just talk through sensors and then a little bit about gateways, and we'll sort of move left to right to take you through it. But don't worry, it won't get too technical, I promise. We can do that, the technology, later. So the things themselves in the Internet of Things are either really sensors or actuators. So sensors measure and detect change. So they might be in a fridge measuring the temperature, they might be in a lift listening to the noise, and then you have actuators which do something. So that could be something that opens a window in a greenhouse, or turns on a garden irrigation system. Regardless, all of these devices, sensors and actuators, need three things. They all need a power source. They all need a unique identity so that we know which device is actually talking to us. And they all need a means of communication. And that means of communication can be, I mean, we're all familiar with Wi-Fi and 4G and Bluetooth. There's a whole range of different technologies that have different properties. And the one we're talking about today is called LoRaWAN. And that has some particular properties that make it very good for dealing with sensors. So one of the great things about it is that the batteries in a LoRaWAN sensor can last years, which, if you imagine you've got a sensor in a lift, you want the battery in that to last you years. So LoRaWAN is a good use there rather than, say, 4G, because you will be recharging it every day. Now the key features about LoRaWAN is the batteries last a long time. It can also transmit messages over a very long distance. When I say a long distance, we're talking several kilometers. So it's far further than you can transmit with Wi-Fi. So that sounds great. Why isn't everything like that? Well, the reason is that there's a trade-off, and whereas Wi-Fi is fantastic for streaming Netflix and sending pictures of your cat on Instagram, you can't do any of that with LoRaWAN. With LoRaWAN, the amount of data that you can send is tiny, less than a tweet, and it's the good thing about it is that you can send thousands of them, or thousands of devices can send messages. But it does mean it isn't suitable for people to browse the internet. So you can't use it as a person, but it is ideal if all you're trying to send is the temperature, or whether there is a car parked on you, or whether a gate is open or closed. Those kind of things you can send very comfortably within LoRaWAN. And that's why the council's excited about it, because there's a lot of smart city and smart rural area type uses that they're going to be exploring, both Norfolk and Suffolk. And indeed, I think now there's over 30 local authorities in the UK looking at doing something with LoRaWAN, but Norfolk and Suffolk are ahead of most. So good uses then. For LoRaWAN, you can avoid manual inspections. If you can avoid manual inspections, then you can save money, but you can also therefore be monitoring things 24 hours a day rather than once a week whenever you do the inspections. It's great for condition monitoring and sending alerts. So that could be a safety thing like a smoke alarm. It could be the temperature of a fridge, that kind of thing, and it could be security as well. You know, whether fire doors are closed, whether the building is locked or not. Preventative maintenance, which we've talked about. If you can avoid a lift breaking, then life is better for everybody. Counting and measuring things, whether that's people, whether it's vehicles. That's a very good use of the sensors. Tracking assets, that's not something I've talked about, but you can imagine perhaps shipping containers coming on the backs of lorries into Felixstowe port, and maybe it would be useful to the port to know which lorries were coming and how far away they were so that they could actually schedule them in to the right bit of the port to drop off their shipping crates. And remote control, so using actuators to actually turn something on or turn something off. These are all good uses of LoRaWAN. There's also some bad uses of LoRaWAN. It isn't suitable for sending large amounts of data, as I mentioned. It's very small amounts of data. It's not suitable for continuous data either. So you can't, for example, track that shipping container every 5 seconds, but you can every few minutes. It's radio technology, so for some mission critical type things, radio just isn't reliable enough. So it's not always ideal for that. And also you don't get a truly instant response. So sending a message can take a few seconds before it is received by the application, and there's certain uses where a few seconds can really matter. So as long as you don't mind it taking a few seconds, then it's fine. The LoRaWAN network that we use is called the Things Network, and the Things Network it's a global network now. It started in 2015 by these two guys, Johan and Winker, in Amsterdam, and they heard about LoRaWAN and decided that they could create an Internet of Things network across the city for a few $1,000s or 10,000 euros. And they persuaded some of their friends to host these gateways. Now that's grown, as you can see, to now it's in 150 countries and there's 135,000 contributors. In the UK, there's an awful lot of people doing it now. I think there's just over 1,000 people involved. There's hundreds of communities, but Norfolk and Suffolk are particularly well placed. So what you can see here is each of the little circles is indicating a gateway in the county, and this is just the beginning. Norfolk and Suffolk, I think between them it's 220 gateways that are going up in the region. So the coverage, and remember that the coverage can be several kilometres, so the coverage is going to be excellent. So back to some good uses depending on where you are. So in towns, then parking space sensors, monitoring people flow down a high street. In fact, in Felixstowe, there was a project a couple of years ago that I was involved in, looking at how people flowed from the seafront up into the town, because they have to go up more or less up a cliff to get into the town centre. And looking at infrastructure, so Watford Council has this rule that it doesn't want to do inspections anymore. It wants the things out there, the bits of infrastructure, to tell the council when something's gone wrong. And flood warning as well is another common use case. In rural areas, then things like remote equipment on farms, tractors, quad bikes, tracking those and making sure that they're safe. On-demand maintenance, so rather than routinely going out to empty a tank, you would empty it when the tank tells you it needs emptying. Precision farming we talked about earlier with aeroponics, and security is a big concern as well. So you know, tracking that you're not getting break-ins in the middle of the night and people running off with your sheep. But it's not just farming. I mean, that's true of any sort of remote buildings that you might want to keep an eye on. In and around the home, smart energy management, people looking at how much you can actually look at and reduce the amount of energy bill of a block of flats if you treat it as a whole thing rather than individual apartments. There's all sorts of good experiments going on with that. In offices, knowing around hot desks, particularly now with COVID, making sure that people are nicely spaced apart. You can monitor the occupancy of desks, whether meeting rooms have got people in them or not. And then more sort of fundamentally down to the basics, monitoring things like leaks in bathrooms, broken boilers, those kind of things. Building management is a huge area for the Internet of Things. I think one of the big selling points there is that because these devices are battery powered, you don't need to have all the installation costs of wiring, and it means you can retrofit this equipment really easily. Preventative maintenance in business and industry is a big deal. transport and logistics, particularly within a region, is a good use, or within a warehouse, in fact. So people looking at the location of different pallets. Monitoring goods, it's very much in the news with the recent Brexit things, where you've got lorries, fishermen worried about getting their live catch over to Europe, and pollution monitoring, of course. So air quality, or indeed the quality of the water in rivers. So if it is something that interests you, it's completely free to sign up to the Things Network. It means that any devices you connect in Suffolk and Norfolk will make use of those gateways and other people's Things Network gateways around. And it also means if you are in Amsterdam, or if you're in Reading, or any of these other places that has a LoRaWAN network, your devices work there as well, right across Europe. I've got some links here. I understand this is being recorded, so I'll make sure these get shared. I think they're on the website anyway, but the Things Network has some fantastic learning resources, some great documentation about how to get started, and some videos. You can start your own community, but be aware there's several already started in Suffolk and Norfolk, and there's forums there so that you can actually meet and converse with other people. And lastly, we're running some future events through this innovation network, so keep an eye out for those, because we'll be hopefully doing some hands-on work. For those who are interested in getting started, a bit ahead of the game, you can get started with a sensor kit, which is just plug and play sensors if you want to experiment with sensors, and something called a Things Uno. If you can program an Arduino, then you can get started with that. That will talk to the Internet of Things through the Things Network, and you can connect your sensors to it. You can, but you probably won't need to, buy your own gateway. As I say, you won't be needing to in most likelihood, because of the coverage that Norfolk and Suffolk are providing. Okay, I think that is it. So if you have any questions, please put them in the Q&A, and at the end of this session, we'll be going through and answering the ones that we can answer today, and then following up with the others. But I will pass back now to Simon. Thank you.
Thanks very much for that, Mark. Really interesting presentation. Okay, next up, we're going to have a short video presentation from Matthew Applegate of the Creative Computing Club. He's going to talk about an educational program that we're launching alongside the LoRaWAN network. So we should hand over to that.
Hello, my name is Matthew Applegate, and I'm here to introduce the Creative Computing Club Internet of Things project. The Creative Computing Club was founded in 2012 in Chirp Library in Ipswich with just 10 young people. And over the last 9 years, we've grown to work with several hundred young people every single week, in person and now online. Our goal is to provide worthwhile and engaging technology sessions, so that way young people can feel connected to the world of technology around them. So we're very, very excited to be a part of the Norfolk and Suffolk Innovation Network. We've done some very exciting projects in the past around AI with IBM using their Watson API, and we've done lots of exciting projects around VR, but we're super keen on getting involved in LoRaWAN. So this is a great opportunity for us and our young people to understand the technology and build exciting new applications and hardware around it. We do have considerable experience in working with LoRaWAN already. We were one of the first sites in Ipswich to have a LoRaWAN gateway, and it allowed early adopters to build projects and raise awareness. Several of our young people actually used it for their GCSE and A-level projects in 2019 and early 2020. Our project has 4 phases to it. The first being the training. The Creative Computing Club will deliver training sessions to over 60 young people across Suffolk and let them use existing gadgets and applications to take advantage of the new network we have in place. The second phase of the project is the brainstorming. The Computing Club will facilitate the creation of several different design projects created by young people to fully explore the different positive uses of the LoRaWAN network. The third phase, the Computing Club will run an internal group-wide competition to select 5 projects to go forward to a Suffolk-wide competition. There'll be approximately 5 teams in total, culminating in an award ceremony in Ipswich or online when and where applicable. The Creative Computing Club will then host the competition with all the group winners. There's going to be the teams will be approximately 5 to 10 people, and we're looking at having a ceremony in Ipswich, hopefully. The groups will be formed from students all across Suffolk. That way we can get as many different people involved as possible. The training sessions are looking to start in late February, culminating with an award ceremony in late March, early April. If you have any questions, you can contact us on info@creativecomputingclub.com. You can follow us on CCC Suffolk Twitter or on Facebook, or you can check us out on our website at worldwideweb.creativecomputingclub.com. Look forward to hearing from you. And if you want to get your young person involved in the competition, do get in contact with us, because we're super excited about this project, because it's a really useful thing to have here in Suffolk. Thank you very much.
Really excited to get that project underway. So next up, we're going to have a presentation from Brigitte Soldano-Carter, who's going to talk about Suffolk's ADEPT program and how LoRaWAN is playing a part in that project and how it's going to get things underway.
So hello, I'm Brigitte Soldano-Carter. I'm the Development and Delivery Manager for the ADEPT Live Labs project, and I'm going to take you through the project that I'm working on and how we're working collaboratively with the LoRaWAN network team. Okay, so the Department for Transport funded ADEPT, which is a project board within the Department for Transport, £23 million to look at innovative ways of doing some research within transport and highways. So from that 23 million, Suffolk County Council were allocated 4.41 million to look at innovative research within a number of sectors within their highways team. And we're currently working with 15 smart technology companies across the UK and into different parts of the world, such as Canada and France. So we're trialling a number of different sensor researchers, and we're working with the 15 smart companies. Some of the things that we're looking at doing is using sensors to test road surface temperature. And we're hoping to revolutionise the way that we do gritting and make savings, but also reduce the impact to the climate. We're also using air quality sensors, and we're using these within our current street lighting infrastructure, and we're using a composite cowl to house the air quality sensors at pram height. And this will allow us to monitor and see what our children are ingesting on a day-to-day basis. We're also looking at some renewable energy such as solar and wind and other types of research projects that I'll tell you about later. So there's a lot of excitement about what we're doing, especially about our dashboard with BT. There's hope that we're going to be able to share it with other local authorities and then further either nationally and internationally to inform people of how they can ingest their data onto one bespoke dashboard. We're trialling a number of different sensors from low cost, medium and high to see how they work within the 3 or 4 seasons that we're using to test them, and hopefully this will show some savings for other local authorities. For Suffolk County Council, I'd see ourselves as being quite unique because we have urban, rural and coastal areas, which allows us to get a different view. So we're working with 4 key partners. I've already spoken about BT. We're also working with the University of Suffolk. We have an associate researcher, Dr. Hannah Steventon, will be providing sensor data and a business case for each product and sensor deployed within the Adept Live Labs project. We're also working with the BSI, formerly known as the British Standards Institute. So we're looking at them developing a digital landscape with a view to looking at how they can inform business cases and standards moving forward. We're also working with Proving Services, who are looking to develop an asset portfolio builder for use by other local authorities within the smart cities arena. If we move on to think about smart communications, we're working with 4 different types of networks: radio UMB, mesh and 4G, and obviously the LoRaWAN network. This is offering us a really exciting opportunity to work together. So if we move on and look at how the LoRaWAN network is benefiting the Adept project, the LoRaWAN project has provided us with a network for our Adept project to allow us to research different sensor types and bring people to work together for the first time. One such innovation is to use camera sensors to manage and monitor volumes of traffic and different classifications of vehicles, and this will be ingested into one central management system. Another user case we're working on with the LoRaWAN team is to manage silt and water levels within gullies. And then this alerts us to any intervention that's required and allows us to be reactive and not dependent on cyclical monitoring. So one of the most interesting aspects of this role is the research into supporting colleagues who are working with vulnerable adults and enabling them to be within their own home setting and independent for longer. This is about facilitating short journeys for the vulnerable, understanding there may be some risk because of cognitive impairment. We are working with 3 different smart tech companies who are looking at sensors for the home, in-home, and also wearables. Sensors that can be worn around the wrist, which will monitor the individuals or the vulnerable adult in their home setting. An example of this is about monitoring somebody's behaviour pattern. So if they usually put their kettle on at a set time each day and they don't, an alert will be sent to their carer or designated person. While these are in the home, we are also looking at wearables for the vulnerable people. This will allow short journeys, an example being they usually go to the post office but no further. If they go past the post office, then this will send an alert to their carers or designated people. This offers confidence for the families and allows independence for the person. So in addition, we are looking at sensors that monitor water leaks, such as leaving the taps on, but also looking at lighting a pathway to the bathroom at night, which is hoping to reduce falls. The levels of carbon dioxide and monoxide levels will also be monitored. So as you can see, the LoRaWAN network has aided us in 3 elements of our project. This is a good collaborative partnership and has worked well for the people of Suffolk.
Okay, so some very interesting details around how the LoRaWAN program is helping support that Adept program with some innovative uses. So I'm just going to talk to you now about Suffolk's gateway deployment, about where we've got gateways, what our deployment strategy is, and what our future plans are. So in Suffolk, we've currently got around 50 gateways installed or planned across Suffolk. We've got them generally installed at the moment on Suffolk County Council buildings, including a number of fire stations. What we found is that at the fire stations where they've got the fire towers, they make ideal points to host the LoRaWAN gateways because of the height, so we get improved coverage from them. We've got local gateways installed on lampposts. We've got 20 of the gateways currently live in many towns across Suffolk. We've got additional gateways going live all the time, to the point where I think we had one go live yesterday. We just had another installation carried out yesterday as well. As you can see here, this is the map of the gateways in Suffolk. So the green ones, as you can see, are the live gateways. We've got the ones in orange are planned, and then the ones in blue are where the installation's been carried out, but we've not yet commissioned them into live service yet. So as you can see, we've already got really good coverage across the county, which will also help get us towards the aim of getting full coverage across Suffolk, and with obviously Norfolk County Council covering Norfolk as well. As I say, we're aiming for full coverage across the county. We're trying to identify further sites all the time, and we're constantly surveying sites to ensure we get maximum coverage out the gateways that we deploy. As Mark touched on earlier, the project for Suffolk and Norfolk is to try and get 220 gateways installed across both counties. That's 100 external gateways and then 10 internal gateways at each county. This will make the network, once it's completed, the largest free-to-use public sector deployment in the UK, which we're both very proud of. How can you help? So we're constantly on the lookout for additional locations, especially in smaller towns and villages. If you've got access to a taller building or higher locations, they're obviously ideal. If you're able to host a gateway, we'd be interested to hear from you, which we'll provide some contact details for shortly. We'll consider hosting gateways in either public or private sector sites, so there's no issues with that there. So we have got some questions that have come in through the Q&A panel, so I was going to invite Mark Stanley back in to help go through some of those.
Hi, Simon.
Hi there, Mark. So first question we've got, which was around, are there any issues with electromagnetic interference, and will this influence location of gateways and IoT devices?
Yeah, that is a good question. So a couple of things to say. LoRaWAN is very low power, far lower than a mobile phone even. What that means is it needs to be really good at hearing very quiet messages, and it uses a technology called Chirp and spread spectrum technology, which was actually developed during, I think it was the Second World War, to listen to the sound of submarine propellers across the world. So it's very good at dealing with noise. So LoRaWAN's not too susceptible to electromagnetic interference itself, and because it's low power, it doesn't create any real electromagnetic interference either. That said, it is radio, so all radio has a certain amount of susceptibility to this. Hope that answers it.
Okay, thanks very much for that, Mark. So next question I'll quickly answer. So it says, will the LoRaWAN network be restricted to county council projects, or will it be a public community network? So the intention of the network is for it to be free to use for all, so it's not restricted to any one body. We're providing it free of charge, looking to utilise our own infrastructure to provide the connectivity. But essentially we want it for everyone to use, so connectivity, public, new startups and things like that. So, we want everyone to use it as feasibly possible, really. We've got another question in, which if we both have a go at answering this one, which is, what in your view is the best use case in the UK so far? So do you want to go first, Mark, and then I'll say about the one I know about?
Yeah, I'm struggling to narrow it down. I guess my heart says my absolute favourite use case at the moment is a project called Push to Talk by a company called DefProc Engineering in Liverpool, and it is a button. It's a simple button, and it is given to people who are isolated so stuck away from a community and they're isolated. And the idea is you push the button, it sends a message over LoRaWAN to an application, and then using the actual phone connects you to other people who are also isolated, and allows new conversations to happen. So it just allows people to talk to one another and tries to break down social isolation. So for me, that's my favourite. But if I was a business, then the building management side of things, I think, is probably the most profitable area at the moment to be working in.
Okay, thanks for that. I'm just going to cover on one of the ones that I've sort of come across as part of the project team. It's one used by Norfolk County Council, where they've put temperature sensors in roads, so they use that to sort of help dictate whether they'll grit roads or not.
Yes, an excellent business case.
Yeah, it came about from where they had sort of microclimates develop in certain areas near the coast. So I think it was Great Yarmouth was one of the areas, and where they found that they would potentially grit roads or not grit roads, and that the temperature would be inaccurate from the sort of the current monitoring tools. They put sensors in road, and they've been a lot more accurate and saved a tremendous amount of money and effort by gritting when they need to now, rather than when they sort of predict to. So I think that's just a really good practical use case that you can easily see the benefits from, and I look forward to establishing more of those within Suffolk as well. Selfish here. Okay, we've got a few more questions. So got one, if you want to try this one, Mark. Which sectors will benefit from using LoRaWAN? I think it's potentially all, isn't it?
It is. I'm trying to think of areas that I haven't come across anywhere that isn't using it. So I mean, from something like farming, it's getting used a lot there because it's in a remote, farms tend to be in fairly remote areas where telecoms is hard to get hold of, and you can't really persuade Vodafone or O2 to stick up a mast for you. But you can, of course, put a LoRaWAN gateway up anywhere you fancy, and there's no fees for it, so it's a nice low cost thing to do. So I think that benefits. But right at the other end, in super high tech world, there's a company called Lacuna Space who is putting LoRaWAN into space on satellites. So it really covers a diverse area. I think pharmaceuticals, so the sort of monitoring of conditions, anywhere where you're monitoring conditions of something, where there's something valuable that you stand to lose. I struggle to think of an area. I mean, I guess I don't know, football maybe doesn't benefit from it so much, but yeah, by and large, I think most sectors will stand to benefit from LoRaWAN. In specific use cases, though.
Thanks so much for that, Mark. So we'll just do another two questions. So there's just one around connecting of IoT devices. And the question is, are these able to connect to any signal, or should we expect and plan for sensors to be proprietary to each, i.e. only LoRaWAN devices work on LoRaWAN, or devices work on Wi-Fi, 4G or LoRa, etc.? Is it simply a function of the device design? What's the now? Yeah,
so yes, a tricky one to answer. I will give it a go. So I've just realised as well, we've got a gateway on the Reading Football Club's stadium, and I know of an American football stadium that is using LoRaWAN for all its concessions within the stadium. So even sport. So this question, yeah, a LoRaWAN device, so a LoRaWAN radio in the device will only be able to send LoRaWAN messages. However, there are devices around, and there's a great company called PyCom. I think they're based in Guildford, and they have a device that you can build sensors around. So it's the radio bit that has got narrowband IoT, it's got Sigfox, it's got LoRaWAN, and I think it's got Wi-Fi on it as well. So there are devices around that will allow you to use multiple networks depending on what's available in your region.
Okay. Thanks for that. Okay, so I think we've got quite a few questions coming. We'll just try and finish off with a couple more. So someone's asked the question around what's the cost of hosting a gateway. From the perspective of us providing it, we're not charging people for using the network. It's a free to use network. So it's there as an asset for people to make use of. So there'll be no charges from us. Obviously, you've got charges for your sensors and equipment you need to set up on there, but there'll be no cost for making use of our network. And then there was a question in reference to Councillor Hicks's earlier reference to Suffolk County Council being rural, and is the agricultural sector here interested in the potential of LoRaWAN to improve productivity? Can we help them run pilot use cases? I don't think we've had any specific conversations yet with any of the agricultural sector around the network, but we would be interested in having conversations, and I think we'd be interested in helping get pilot uses set up, particularly if we've got other parties who could help bring some innovation to those and some ideas as to things they could try. And at the same time, if we can put people in touch through the network, we're happy to do that. It's
a very thriving area for LoRaWAN to be involved in, for sure.
Okay, so I think that's the last of the questions we'll pick up today. As we kind of touched on earlier, we will provide answers to all of the questions after the session. So we'll send them through if we've got contact details. And we'll also share them on the website, which we'll show you the address of shortly. Okay, so that pretty much concludes all of the presentations. So I just wanted to go through and say thank you to people who've participated today. So in particular, all of our presenters. So thank you very much to Councillor Matthew Hicks, Mark Stanley, Matthew Applegate from the Creative Computing Club, and Bridget Sodano Carter from the ADEPT programme. Special thanks to the New Anglia Local Enterprise Partnership, who've provided funding to Suffolk and Norfolk County Council to help get the project off the ground and get it moving. To my colleagues in Norfolk County Council, in particular Kurt Ferreri, who sort of was a real driver to get this programme going, and his wider project team have been really helpful to getting Suffolk going through their sort of earlier experience prior to the joint project going, and then the sort of joint work we've undertaken since. To my wider project team as well, in particular to James Reeve and Russell Drake, who are driving the installation of the gateways and the project going forward and helped to pull together today's event. Also the Suffolk Fire and Rescue Service, who have really enabled us in getting a lot of the gateways up and running across Suffolk, giving us ideal places to host them on the fire towers at a number of the fire stations. And lastly, Measured Brilliance, who are a partner we've got involved, who've produced a website for us and working on other things around the publicity and things like that for the event as well. So contact details for the Innovation Network. So we've got IN Innovation Network at suffolk.gov.uk and the same at norfolk.gov.uk if you've got any sort of county specific questions. We've got the new website up and running now, which is www.innovationnetwork.uk. And thank you very much for everyone for attending the event today, and we'll hopefully speak to you all soon.